Hello and welcome to another one of these ADD videos. Today we're going to be looking at an example of a t-score in which the population standard deviation is unknown. So what happens here? Well, we're going to have to calculate our test statistic, get our critical chart value, and compare the two. So if you remember, there are two methods. One was absolute value of t calculated. If that's greater than your chart value, then you reject it. The other one, you're going to need to graph and look at where your t's are based on your research hypotheses. So let's look at this example here. It doesn't matter what it's applying to, just look at the numbers, just pure calculations to get the fundamental concept down. And then we can do a more complex example on another video. So here we have a population mean of 4, and we have 25 data points, and their mean is 3.9, and their standard deviation of that mean was 0.4. So from that you can calculate a test statistic by using this formula over here, and your test statistic is going to be equal to negative 2.5. If you were to plug that into your calculator, you're going to get a negative 2.5. Okay? So now what we got to do is we got to get criteria to reject the hypotheses. In this case, I went ahead and just applied all 3 research hypotheses. The null is equality, and then there's the greater than, the less than, or the not equal to version. But they're all going to have the same chart value. The only difference is actually the two-tailed will not, but the one-tails will have the numerical same values, just it'll be either plus or minus. So let's look, we have to calculate our degrees of freedom in this case. So degrees of freedom is going to be 25 minus 1. It's the number of observations minus 1, which is 24. And so when we're looking for this t-score, we're going to have a t of 0.1 comma degrees of freedom of 24. So if we go to a t-score chart, I just happen to have one handy right there. We come to the top, we look for the probability across the top row. Make sure you're doing the one tail here for the first two, and then we'll do the two tail for the second one. So the degrees of freedom was 24. Come down to 24, this row right here. Oops, it's not working. There we are. And we stop at degrees of freedom, two tails of would be 0.2 right there. So the 1.318, this value right here, I believe is what we need, yeah, because that's the 0.10, right, for the one tail. So the way it works in method 2 is you assign your, if you're looking at the greater than value, then it's a positive 1.318. That's what you're using as your rejection criteria. If you're looking at less than research hypothesis, you would put a negative 1.318. And then if you're doing a two-tail test, you would have to actually get a different t-score value. You'd go to the two-tail version of 0.1. So not that 0.1, but this one right here for two tails. It's easier actually if you think about it. What you're doing is you're taking that 0.1 and you're dividing it by 2, cutting the rejection region in half. So that's why the two-tail column corresponds to half the p-value or alpha value on the one-tail column up here, right? Does that make sense? Because you cut the p in half, so you should have 0.05. But if we're, some people oversimplify charts and then make them a little bit more complex than they should be. So that would change that to 1.711, and what we would do there is we would have a negative 1.711, 1.711. Okay, So if we were doing the greater than, our value was way over here at negative 2.5, so we would not reject. There's not enough evidence to reject. Here, on the less than, though, we are in the rejection region. That 2.5 negative is in the rejection region, so we would reject null. And then here, again, one side, we are on this side, so we would reject null in this scenario as well. Okay? So it's all about your alpha values and your degrees of freedom for these. So just practice as always. You learn how to use the t-score table, become familiar with that, and learn how to apply it. Okay? Hope I've cleared up any confusion you might have. Thank you and have a nice day.